Hello my dear friends, welcome to our YouTube channel ADC Max. In this video, we are going to learn something about how to solve the second or higher order homogeneous partial differential equation. Already we know that what is z with the function of x. In the case of the second or higher order homogeneous PDEs, the complete solution of z is consisting of two parts. One is called the complementary function, another one is particular integral, isn't it? We already know the procedures to get the complementary function and the particular integrals. So let us see how we are going to get these complementary functions and the particular integrals. Okay, see the question number 1. Question number 1 is solve d squared minus 5dd dash plus 4d dash squared into z is equal to 0. Before going to that, I would like to just recollect in this homogeneous second order partial differential equations, there are two operators, one is d, another one is d dash. D represents dou by dou x, d dash represents dou by dou. Got it? The same way, what is the reverse? 1 by d, 1 by d stands for, what is the inverse of the differentiation? It is the integration. Got it? Similarly, what is 1 by d dash stands for? It is the integrating with respect to 1. So please keep in this your mind. Now let's see the problem here. D squared minus 5d dash plus 4d dash squared is equal to 0. So I think already I told you that, as we know already, from the left hand side we will get the complementary function, isn't it? Right? From the right hand side we get the particular integral. But in this problem, the right hand side is 0. So there is no need to find out the particular integral. The complementary function itself acts as the complete solution. Clear? Now how to get the complementary function? Now what is the order of the given PDE? Second order. So there are possibly two routes. Let us see that. So how to get the complementary function? So to find the complementary function, let us assuming that there are two operators. What are they? D and D dash. So I assume myself D is equal to some parameter m, D dash equal to 1, and the right hand side is 0, but already the right hand side is 0, no problem. So we will get, what we will get? We will get the subsidiary equation, is often called as auxiliary equation. Why it is called subsidiary or auxiliary? Because when I substitute d equal to m and d dash equal to 1, I am getting that m squared minus 5 into d equal to m, d dash equal to 1 plus 4 into d dash equal to 1 into z equal to 0. Either this equal to 0 or this equal to 0. That means that either m squared minus 5m plus 4 equal to 0, or otherwise z equal to 0. But sorry to say this, z equal to 0 means there is no partial differential equations. Isn't So that's why we avoid that case. So we can take it as the one of the sub-equation. Subsidiary equation is often called as auxiliary equation. Is m squared minus 5m plus 4. What is the degree of this equation? 2. Why? Because of the given second order partial differential equation. So the PDE order 2 means we get the second degree. Now when we solve this equation, I am getting the two roots. So when we solve this one, I am getting the two roots, namely m1 is equal to 1 and the m2 is equal to 4. So now the roots are real and distinct, isn't it? So the roots are real and distinct. So once the two roots are real and distinct, as we know that, what is the complementary function? The complementary function is, we introduce the complementary function for each root in the form of f of y plus mx. So here it is f1 of y plus m1x plus f2 of y plus m2x. Now let us substitute in the place of m1 equal to 4, m2 is equal to 4. We will get the required complementary function. Is right, sir? Okay. What about the particular integral? In this case, the right hand side is 0. So there is no need to find out the particular integral. So that the complementary function itself acts as the complete solution. So this is the answer. Once I repeat this, the given is second order That answer is 0, so no need to find the PI. Complementary function act itself as the complete solution. Now, the second order means we will get two roots. So that's why after the replacements by the parameter d equal to m and d dash equal to 1, we are getting the second order, that is second degree quadratic equation. But you know how to solve the quadratic equations by using the quadratic formula minus b plus or minus square root of b square minus 4ac by 2a, or by using the remainder theorem or factorization techniques, whatever it is. But we require the roots only. Once we know the roots, then we can easily write the complementary function. Right? Thank you, sir. Thank you for watching this video. Thank you.